let's talk about wolves. We're going to get into some wolf facts, but more specifically, we're going to cover a couple different theories regarding these guys. The first one is the survival of the fittest. So there are three main points to this theory. The first point is that there is variation in traits within a species. You can see this with the wolves right here. They're all slightly different colors, slightly different builds. Next point is that these traits are heritable, meaning they can be passed down from parents to offspring. And then the third point is that some traits are more advantageous than others. In other words, there's a survival advantage. For example, if gray wolves were going to go extinct, if we somehow wiped out all the moose in their habitat, they would go extinct because they need those moose to survive. If an individual gray wolf has a genetic mutation that makes it better at hunting moose, that wolf will survive longer and have more pups that also have that advantageous trait. Over time, the frequency of that trait will increase in the population. Eventually, most of the wolves in the population will have that advantageous trait, and the species as a whole will become better at surviving and will thrive. If, however, there was a genetic mutation that made them worse at hunting moose, the opposite would happen. It would go from being a more common trait to a less common trait over time. Basically, the environment is constantly acting as a filter for traits. Only certain traits will be advantageous in certain environments at certain times. An example of this in action with wolves is the dire wolf. The dire wolf was bigger than the gray wolf, so it would have been better at hunting big game. During the Pleistocene epoch, there were lots of big game animals like mammoths and mastodons, so being bigger was an advantageous trait for wolves. Over time, the frequency of this trait increased in the population, and we ended up with the dire wolf. At the end of the Pleistocene epoch, the climate started to warm up. There were fewer large game animals, and smaller animals became more common. As a result, being smaller became more advantageous because smaller wolves could run around and catch those smaller animals. The dire wolf went extinct, but the gray wolf still exists today. So basically, the environment is always changing. What might be an advantageous trait at one time might not be an advantageous trait later on. A classic example is with body size. During the Ice Age, it was advantageous for mammals to be larger. So baby mammals were born larger than they are today. Today, it's more advantageous for mammals to be smaller. So baby mammals are born smaller than they used to be. Wolves are no exception to this rule. A study published in 2019 found that gray wolves today are actually much smaller than they were just a couple thousand years ago. All right, moving on to the next theory. The second theory is the sexual selection theory. This is essentially the idea that organisms evolve to have traits that make them more attractive to the opposite sex. Take a look at these wolves again. Sexual dimorphism. The males are typically larger than the females. Larger males can intimidate other males, and that means they're more likely to breed with the females. So if we were to plot the size of males over time, we would see something that looks like this. During the Pleistocene epoch, the average size of male gray wolves was around 120 pounds. But as time went on, they got bigger and bigger. Today, the average size of a male gray wolf is around 170 pounds. That's a pretty big difference. But why? Why did they get so big? Well, it's likely due to sexual selection. Females likely preferred larger mates, and over time, males evolved to become larger. Again, this is just one example. There are many other examples where one sex gets bigger over time, but what about the other sex? Do they evolve to be smaller? Yes. Take a look at this graph again. The females seem to stay relatively the same size. So what does that tell us? It tells us that sexual selection isn't the only force acting on body size. There must be another force that is keeping female body size relatively constant, while the males get bigger and bigger. That force is natural selection. Natural selection is likely acting against larger females, because larger females require more food to survive. So basically, when it comes to body size, there's a balance between being too small and being too big. If you're too small, you'll be less successful at defending yourself and your pups. But if you're too big, you'll require too much food to survive. Thanks for watching.